Okay, so first section is section 12.1. And in this section, we're going to be focusing on properties of the exponents. First thing I wanted to do is talk about general simplifying. We follow PEMDAS. It might have been a few years since you saw that acronym before, but what this stands for is we work on parentheses first. Then we do our exponents. Next, we take a look at multiplication, division, addition, and subtraction. With multiplication and division, and with addition and subtraction, we do whatever comes first. From left to right. Second, make sure you copy that down. I'll show you some examples before we get into some other topics here. All right, so if I asked you to just simplify and I asked you to do -1 squared, which this means is you're squaring what's in parentheses, so -1 times -1, which is just 1. That would be the answer. That's totally different than if I asked you to do -1 squared. What this means is that you square 1 and then you multiply it by -1 second. So this would just be -1. Obviously, those are two different answers. You have to be careful when you're doing it. One-half squared is the same thing as just 1/2 times 1/2. And when we're multiplying fractions, we just go straight across. So like 1 times 1 is 1, 2 times 2 is 4. And then the last one like this. I'll ask you to evaluate. Now, evaluate just means to plug in numbers or variables and simplify. Simplify just means combine like terms. So just a little bit of vocabulary there. But this last example, if I asked you to do 3x to the third, if x was equal to -2. What you'll do is you just put -2 in for x. We have exponents and we have multiplication. So if you remember the PEMDAS that we talked about earlier, we want to make sure that we do the exponents first. So we're going to do this part first. Then we're going to multiply by 3. So this would be 3 times negative 2 to the third is negative 8, which is negative 24. All right, now let's get into some rules of exponents. And there are about 5 of them. First rule is called the zero power property. And this just means anything to the 0 power is 1. Next is called the power property. Whenever you have a number to a power to another power, you multiply those. Next is a product property. When you have a base to a power times the same base to a power, you add exponents. So I'm just using some vocabulary here. This is called the base. This is called the exponent of power. They mean the same thing. Next is the quotient property. You're dividing the same bases. You subtract their exponents. And then we have the power of a product. Which means if you have variables, powers inside of parentheses, what this means is you just multiply the powers times what's outside. So it could be the same thing as x to the AD, y to the BD, all over z to the CD. And I'll show you some examples with actual numbers, but we use letters to generalize these rules. So let's get to some examples here. I'll just ask you to simplify. So what if we had 2x to the second times negative 3x to the fourth? Something we could use is called the commutative property. It just means that order doesn't matter. With multiplication or addition. And what I mean by that is if we're multiplying 2x squared times negative 3x to the fourth, we could put the 2 and the negative 3 next to each other. And we could put the x to the second and the x to the fourth next to each other. And then just multiply. It's a little bit easier if we just change the order. 2 times negative 3 is negative 6. And then using the product property, 2 plus 4 is 6. No different if we just add more numbers. So if we add 2x to the fifth times negative 3x to the second times 4x to the eighth, what we could do is just rearrange all these numbers. So 2 times negative 3 times 4, and then x to the fifth times x to the second times x to the eighth. The way we do this is we do 2 times negative 3 is negative 6. And we just add all these. 5 plus 2 is 7, plus 8 is 15. And negative 6 times 4 is negative 24, x to the 15. If we had 2x squared to the third power. This is an example of power to a power. It's really just 2 to the first. So what we're doing is distributing the 3 times those powers. So this is just 2. 1 times 3 is 3. X to the sixth, or 8x to the sixth. All right, about one a little more complicated, so negative x to the second, y to the third, z to the fifth, to the second. Same idea as the last one, we're going to distribute this power, but this is really a negative 1 in front. So we're going to square that as well. So this is going to be negative 1 to the second, x to the fourth, y to the sixth, and z to the 10th. Remember, when we have a power to a power, we multiply the exponent. There we go. All right, and what about if we did the same thing with a fraction? So if I did 2x to the second, y to the third over z to the fourth, all to the third power. We're going to distribute that third power to everything. So this is 2 to the third, x to the sixth, y to the ninth, over z to the 12th. Or 8x to the sixth, y to the ninth, over z to the 12th. So those are some examples using the power to a power property. We'll look at some other ones here. What if we had 4x to the fifth, y to the third, divided by 8x to the second, y to the first. way the quotient property works, we could really think about this as three separate fractions, like 4/8 is one fraction times x to the fifth over x to the second times y to the third over y to the first. Well, they're really just three separate fractions. This is the same thing as 1/2. 5 minus 2 is 3. 3 minus 1 is 2. More here for this section. Negative 2x to the 0. What did we say anything to the 0 power was? 1, right? So this just turns into 1. And this is just negative 2. Obviously, that's different than negative 2x to the 0, which would just be 1. The whole thing is to the 0 power. Anything to the 0 power is 1. And then take 2x squared over 6y to the third to the second power. Couple different ways we could do this. We could simplify the 2/6 first. Sometimes with these problems, there's no single way to do them. Sometimes there's multiple ways. What I would do is I would just distribute the power of 2 to everything and make this 2 to the second, x to the fourth, over 6 to the second, y to the sixth, which is 4x to the fourth, over 36 y to the sixth. Four over 36 is 1/9, right? We can write our answer as 1/9 times x to the fourth, y to the sixth. But a better way to write it would just be put everything on top over 9 y to the sixth.